Static electricity in a grocery store environment can stem from several factors. Possible causes include improper grounding of shopping carts, low humidity levels within the store, the presence of synthetic materials in clothing and floor coverings, and dry air, which is often exacerbated by heating or air conditioning systems. The National Electrical Code, or NEC, does not specifically address static electricity in grocery stores. However, several articles within the NEC offer guidance on grounding and bonding, which can be applied to mitigate static electricity. Article 250 covers grounding and bonding requirements. Section 250.52 requires the grounding of all exposed metal parts that are liable to become energized. Section 250.130 mandates the grounding of non-current carrying metal parts of equipment and raceways. Article 680 addresses swimming pools, fountains, and similar installations, and while not directly applicable to grocery stores, provides insight. Specifically, 680.26b requires bonding of metal parts and equipment related to pools and fountains to prevent static discharge, highlighting the importance of bonding in preventing static buildup. When investigating a complaint of static shock in a grocery store, there are several steps to consider. Firstly, inspect the shopping carts. Ensure that the shopping carts are properly grounded, and there are no exposed metal parts that could cause shocks. Secondly, check the store's grounding system. Verify that the store's electrical system is properly grounded and that there are no open grounds or inadequate connections. Thirdly, measure the humidity levels. Low humidity can significantly contribute to static electricity. Consider recommending the installation of a humidifier in the store to increase humidity levels. Fourthly, evaluate clothing materials. Synthetic materials are known to generate static electricity. Encourage customers and staff to wear natural fibers like cotton to reduce static buildup. Fifthly, inspect the floor coverings. Plastic or rubber floor coverings can contribute to static electricity. Consider advising the replacement of such materials with options that have anti-static properties. Sixthly, review the ventilation system. Dry air from the heating or air conditioning system can increase static electricity. Adjust the system to maintain an appropriate humidity level. In situations where the store is not in compliance with the NEC or other relevant regulations, enforcement actions can be taken. This could include ordering the replacement of defective shopping carts, requiring the inspection and improvement of the grounding system, enforcing humidity level requirements, or prohibiting the use of certain clothing materials or floor coverings. Beyond these immediate steps, several additional considerations can help in preventing static electricity problems. Firstly, customer education. Inform customers about the potential for static electricity and encourage them to take precautions, such as wearing natural fibers and avoiding excessive rubbing against surfaces. Secondly, regular maintenance. Implement a regular maintenance program to inspect and test the grounding system and shopping carts to ensure they are functioning correctly. It is important to be aware of the potential risks of static electricity to individuals with pacemakers or other medical devices. Static discharge can interfere with the operation of these devices, posing a health risk. Grounding and bonding are crucial concepts in electrical safety and play a significant role in preventing electrical hazards, including static electricity. Grounding provides a path for fault current to flow back to the source, allowing overcurrent protection devices to operate and clear the fault. Bonding connects metal parts together to create an electrically conductive path, minimizing voltage differences and reducing the risk of electric shock. To further elaborate on the inspection process, when examining the shopping carts, pay close attention to the wheels, handles, and any joints or connections. These are common areas where grounding can be compromised due to wear and tear or corrosion. Use a multimeter to test the continuity between different parts of the cart and the ground to ensure a low resistance path. When checking the store's grounding system, start at the main electrical panel and trace the grounding electrode conducted to the grounding electrode system, which is typically a ground rod, ground plate, or connection to the building's metal frame. Ensure that all connections are tight and free of corrosion. Use a ground resistance tester to measure the resistance of the grounding electrode system to ensure it meets the requirements of the NEC. When measuring humidity levels, use a hygrometer to obtain accurate readings. The ideal humidity level for preventing static electricity is typically between 40 and 60%. If the humidity level is consistently below this range, consider recommending the installation of a commercial-grade humidifier to increase the moisture content in the air. When evaluating clothing materials and floor coverings, consider the triboelectric series, which ranks materials based on their tendency to gain or lose electrons when they come into contact with other materials. Materials that are far apart in the triboelectric series are more likely to generate static electricity when they rub together. Natural fibers like cotton, wool, and silk are less likely to generate static electricity than synthetic materials like nylon, polyester, and acrylic. Similarly, floor coverings made of natural materials like wood, tile, or concrete are less likely to contribute to static buildup than plastic or rubber floor coverings. When reviewing the ventilation system, ensure that the air filters are clean and that the system is properly maintained. Dirty air filters can restrict airflow and reduce the system's ability to maintain consistent humidity levels. Consider recommending the installation of a humidistat, which automatically adjusts the humidity level in the store based on preset parameters. The NEC provides detailed requirements for grounding and bonding in Article 250. This article covers the size and type of grounding conductors, the methods for connecting grounding electrodes, and the requirements for bonding metal parts. It is important to consult the latest edition of the NEC to ensure compliance with all applicable requirements. In addition to the NEC, other standards and guidelines may provide further information on preventing static electricity in commercial environments. These may include standards from organizations such as the National Fire Protection Association, or NFPA, and the Institute of Electrical and Electronics Engineers, or IEE. Static electricity can also be influenced by environmental factors such as temperature, air pressure, and the presence of contaminants in the air. These factors can affect the ability of materials to accumulate and discharge static charges. To minimize the risk of static shock, it is important to maintain a clean and well-ventilated environment. The potential for static electricity can also vary depending on the time of year. During the winter months, when the air is typically drier, static electricity is more likely to occur. Conversely, during the summer months, when the air is more humid, static electricity is less common. Consider adjusting the humidity levels in the store based on the seasonal changes in weather conditions. Customer education is an important part of preventing static electricity problems. Provide customers with information about the causes of static electricity and the steps they can take to reduce their risk of static shock. This information can be provided through signage, brochures, or verbal communication. Encourage customers to wear natural fibers, avoid rubbing against surfaces, and touch a grounded metal object before touching other objects. Regular maintenance is essential for ensuring the continued effectiveness of the grounding system and shopping carts. Conduct regular inspections to identify and correct any deficiencies in the grounding system. Test the continuity of the shopping carts to ensure they are properly grounded. Replace any defective components or parts as needed. Static electricity is a common phenomenon that can occur in a variety of environments. While it is typically not dangerous, it can be annoying and uncomfortable. In some cases, static discharge can pose a health risk to individuals with pacemakers or other medical devices. By understanding the causes of static electricity and taking appropriate preventive measures, it is possible to minimize the risk of static shock and create a safer and more comfortable environment for customers and staff. When inspecting the grounding system, pay close attention to the grounding electrode conductor, which connects the grounding electrode to the main electrical panel. Ensure that the grounding electrode conductor is properly sized and protected from physical damage. The size of the grounding electrode conductor is typically determined by the size of the service entrance conductors, as specified in Table 250.66 of the NEC. When connecting the grounding electrode conductor to the grounding electrode, use a listed connector that is suitable for direct burial. The connector should be made of corrosion-resistant material, such as copper or bronze, to ensure a reliable connection over time. When measuring the resistance of the grounding electrode system, use a 3-point fall-off potential method, which involves driving 2 auxiliary ground rods into the earth and measuring the voltage drop between the grounding electrode and the auxiliary ground rods. The resistance of the grounding electrode system should not exceed 25 ohms, as specified in section 250.53 at-war of the NEC. If the resistance exceeds 25 ohms, additional grounding electrodes may be required to reduce the resistance. When evaluating clothing materials and floor coverings, consider the surface resistivity of the materials. Surface resistivity is a measure of the resistance of a material to the flow of electricity across its surface. Materials with low surface resistivity are more likely to conduct electricity and dissipate static charges, while materials with high surface resistivity are more likely to accumulate static charges. The surface resistivity of a material can be measured using a surface resistivity meter. When selecting floor coverings, choose materials with a surface resistivity of less than 1 × 10 to the power of 10 ohms per square, which is considered to be anti-static. When reviewing the ventilation system, ensure that the air ducts are properly sealed to prevent air leakage. Air leaks can reduce the efficiency of the ventilation system and make it more difficult to maintain consistent humidity levels. Consider recommending the installation of a duct leakage test to identify and seal any air leaks in the ventilation system. The NEC provides detailed requirements for bonding metal parts in section 250.92 and 250.96. These sections require bonding of metal water piping systems, metal gas piping systems, and other metal parts that are likely to become energized. Bonding is typically accomplished by connecting the metal parts to the grounding electrode conductor or the equipment grounding conductor using bonding jumpers. The size of the bonding jumpers is typically determined by the size of the circuit conductors, as specified in Table 250.102 of the NEC. In addition to bonding metal parts, it is also important to bond metal equipment enclosures to the equipment grounding conductor. This helps to ensure that the equipment enclosure is at the same potential as the grounding system, reducing the risk of electric shock. The requirements for bonding equipment enclosures are specified in section 250.134 and 250.136 of the NEC. Static electricity can also be generated by the movement of air across surfaces, a phenomenon known as triboelectric charging. This can occur in ventilation systems, where air is forced through ducts and across filters. To minimize triboelectric charging, consider using air filters that are made of anti-static materials. Also, ensure that the air ducts are properly grounded to dissipate any static charges that may accumulate. In areas where static electricity is a particular concern, such as checkout counters or electronic equipment areas, consider installing static dissipative mats or floor coverings. These mats and floor coverings are designed to conduct electricity and dissipate static charges, reducing the risk of static shock. When selecting static dissipative mats or floor coverings, choose materials that are specifically designed for use in commercial environments and that meet the requirements of applicable standards. The use of anti-static sprays or coatings can also help to reduce static electricity. These sprays and coatings are designed to create a conductive layer on surfaces, allowing static charges to dissipate more easily. When using anti-static sprays or coatings, follow the manufacturer's instructions carefully and ensure that the products are compatible with the surfaces on which they are applied. Regular cleaning and maintenance of surfaces can also help to reduce static electricity. Dust and dirt can accumulate on surfaces and create a barrier that prevents static charges from dissipating. By regularly cleaning surfaces with a damp cloth or anti-static cleaning solution, you can help to remove dust and dirt and reduce the risk of static buildup. In addition to the technical aspects of preventing static electricity, it is also important to address the human factors that can contribute to the problem. Encourage employees to wear natural fibers, avoid rubbing against surfaces, and touch a grounded metal object before touching other objects. Provide employees with training on the causes of static electricity and the steps they can take to reduce their risk of static shock. By creating a culture of awareness and prevention, you can help to minimize the risk of static electricity problems in the workplace. When investigating complaints of static shock, it is important to gather as much information as possible about the circumstances surrounding the incident. Ask the person who experienced the shock about the location, time, and conditions under which the shock occurred. Also, ask about any clothing or footwear they were wearing at the time. This information can help to identify the source of the static electricity and determine the appropriate corrective actions. If possible, try to recreate the conditions under which the shock occurred to verify the complaint and identify the source of the static electricity. Use a multimeter to measure the voltage and current of any static discharges that are observed. This information can help to assess the severity of the static electricity problem and determine the appropriate safety measures.